Hello, and welcome to my presentation about the exciting topic of memorizing multiplication facts. My name is Michelle Post, and I am interested in discovering the relationship between multiplication fact automaticity, which is memorizing times tables, and student success and retention in post-secondary intermediate algebra. Without the necessary skills to pass developmental math courses, fewer students will earn post-secondary degrees. Multiplication fact mastery may be one of the necessary skills required for developmental math and college algebra success. According to Boylan in 2011, nationwide developmental math was the most populated of developmental classes, while a common pass rate was only 50%. Further, the course with the highest failure and withdrawal rates in post-secondary education in the U.S. in 2006 was basic algebra. It also happens to be the first course following multiplication fact instruction. Students who lack MFA tend to avoid math more often and suffer personally in areas of vocation, career opportunities, and money management. As such, the inclusion of MFA in developmental math programs would seem beneficial. Research supports that complex math skills are desired, yet lacking in American primary and secondary students, and that MFA is a plausible means to creating new learning trajectories equipped for higher order thinking and problem-solving skills. What remains to be seen is whether these concepts translate to the post-secondary learning environment. In my journey to explore what effect knowing or not knowing multiplication facts has on developmental math completion and success, I propose two research questions. The first, what is the correlation between the scores of the multiplication test and the overall grade for the intermediate algebra course? Of course, the null hypothesis states that there is no correlation. My second research question is, to what extent do the scores of people who withdrew and people who did not withdraw differ on the multiplication test? The null hypothesis states that the means are the same, that there is no difference between the two means. The literature was reviewed and grouped into themes of interest, beginning with the settings, where MFA is formally included, followed by the significance of MFA as it relates to acquisition of future math concepts, anxiety, and neuroscience. And finally, this information was synthesized through the lens of developmental math programs and student outcomes. Primary education systems in top-performing countries, U.S. primary schools, and learning disability programs are three settings where MFA is frequently included in the instruction. Although some post-secondary institutions may offer MFA formally or informally, research of the literature did not disclose any empirically based findings of such, nor present a measured correlation of the effect it may have on student retention, success, and completion. The benefits of acquiring such knowledge include gaining fluency in more complex math concepts while experiencing less frustration and anxiety. Rouse's research in 2014 of a specific MFA instructional venue was a response to Michigan's recent adoption of the Common Core standards. One of the reasons the citizens of Michigan chose to implement more rigorous standards was to better prepare students for college and careers. Despite the ambiguity in the standards, Michigan's leadership interpreted them as to require MFA by the end of the fourth grade, touting the desire for students to be able to solve complex problems without the barrier of basic fact interference. Their assessment of the issue was supported by the unified voice of many middle and high school teachers expressing grave concern over their students' inability to solve complex, higher-order math problems due to lack of MFA. Carr and Alexieve in 2011 conducted a longitudinal study of 206 second-grade students over a 3-year period. The point of the study was to determine whether gender, fluency, or accuracy contributed to growth in mathematical problem-solving strategies. Consistent with previous studies, they discovered that fluency and accuracy are important factors in the development of strategies used to solve complex mathematical problems, and reported that early fluency on basic arithmetic facts has long-term consequences for the development of more advanced strategies and for later mathematics competency. Alternative strategies such as finger counting or calculator use are not equivalent and could render the student ill-prepared into adulthood. Campbell and Alberts in 2009 conducted an analysis of variance on 68 adults on the topic of retrieval efficiency in addition subtraction facts and multiplication division facts. They concluded that in arithmetic, the preferred strategy is retrieval, as opposed to other procedural strategies. Retrieval is superior due to speed, accuracy, and a smaller demand on the working memory. Students who have acquired MFA may also experience less anxiety as it relates to math skills. According to Paul Nolting, anxiety and working memory are negatively correlated. In addition, anxiety retards the movement of information through long-term memory and abstract reasoning. Inversely, less fluency was found in students with higher levels of anxiety. Of course, many variables attribute to anxiety, specifically math anxieties. Nonetheless, educators are encouraged to identify gaps in math fluency and provide interventions to build fluencies as a possible means to reduce anxiety. In its infancy, the field of neuroscience has found MFA to be an optimal brain mapping study. Researchers have discovered that arithmetic facts retrieved from long-term memory stimulate a separate area in the brain than arithmetic computations. A direct correlation has yet to be researched, but the similarities between the discoveries in neuroscience and the concept that automaticity allows freedom to the working part of the brain to perform more complex operations is intriguing. Arithmetic, which includes multiplication topics, and algebra are generally among developmental math courses. The material covered in these two courses consists entirely of elementary and high school math content. Regardless, the courses typically exclude the 4 to 6 week block of MFA instruction. In his 2010 dissertation, Gemmell shared the results of research conducted on the effect memorizing multiplication tables had on high school performance in mathematics. The findings indicated that students who did not memorize multiplication facts scored lower on the comprehensive assessment than students who did, regardless of calculator availability and usage. In light of the current state of developmental math students and programs, findings similar to Gemmell's among post-secondary students might change the sentiment about MFA inclusion. According to Wallace and Gerganis, students who master their multiplication facts have a more positive attitude about their mathematics abilities and further mathematics experiences. Given MFA is as effective in the post-secondary setting, implementing it into the formal curriculum could improve retention and increase degrees earned. My sample consisted of 92 students from 2 different sections of the intermediate algebra course that I teach. Over 70% were fresh people, approximately 60% female, and about 46% were experiencing their first semester at Dixie State University. The plan included administering paper and pencil multiplication tests to students who voluntarily agreed. The test contained 100 multiplication facts of 0s through 9s. 5 minutes were allowed, withdrawals were tracked, final grades were recorded, and the results were compared. The measures consisted of the 100-question multiplication test, withdrawal grades as recorded on Banner, and including students who completed 30% or less of the required assignments, and final grades as calculated on MyMathLab, which is the online delivery system. The data were collected during the first 2 weeks of the fall 2014 semester in classrooms in the Snow Building of Dixie State University in St. George, Utah. I chose 2 analyses. The first was the independent t-test, since I had 2 independent sample means to compare. The intervally scaled variable was multiplication test results, and the grouping variable was withdraw or not withdraw. One of the assumptions for this test was normality for both groups. Normality failed for the students who did not withdraw, so I used the non-parametric test Mann-Whitney-U, and the results were consistent with the independent t. So I used the independent t results for reporting purposes. The second analysis was the Pearson R, since I was interested in the correlation between the 2 intervally scaled variables of multiplication test scores and final test scores. Again, multiplication test scores failed the normality assumption, so I used Spearman-Rowe as my non-parametric test. The results were consistent with the Pearson R, so I reported from the Pearson R test. There was no statistically significant correlation between the multiplication test scores and the overall grade scores. Therefore, I failed to reject the null hypothesis. The scatter plot shows the lack of correlation between the data. However, students who withdrew scored statistically significantly lower on the multiplication test than students who did not withdraw. In this case, I rejected the null hypothesis. The box and whisker plots show the disparity between the means and the ranges. I was surprised not to find a statistically significant correlation between the multiplication test scores and the overall grades, but then I realized that many of the low scorers on the multiplication test withdrew, which I believe changed the picture. with the lower scoring multiplication test score students withdrawing, it came as no surprise to me that there was a statistically significant difference in the means of the withdraw and not withdraw students. So what does all this mean? Well, I was interested in the disparity between the multiplication test scores of students who did and did not withdraw, so I ran a few interesting percentages. For students who scored fewer than 10 questions wrong on the multiplication test, 60% of them passed the class and only 14% withdrew, and some of those withdrew because they tested into higher classes. But for students who scored 10 or more questions wrong on the multiplication test, only 27% passed the course and 50% withdrew. Although I am not statistically significantly surprised, I am concerned. I think multiplication fact automaticity matters. I recommend that we conduct further research on the topic and that formalized multiplication fact instruction is part of the curriculum in developmental math. Thank you.